You know that feeling when you see a sunset that's just so incredibly beautiful it stops you in your tracks? It almost feels like magic. But what if I told you it's actually some of the most elegant physics happening right over our heads? Well, that's exactly what we're going to break down today, the real science behind why sunsets are red.
Right? It's a question you've probably asked a dozen times in your life. Why does the sky just burn with color like that at dusk? And yeah, it feels magical, but the answer is pure, brilliant physics. And it's happening on a massive planetary scale every single day.
So, what is the secret behind this daily light show? Well, here's a hint. It's not really about the sun itself. It's all about the incredible and sometimes difficult journey that sunlight has to take to get to us. And the answer is literally all around us. It's hiding in plain sight. The key ingredient, the big secret, it's the air, our planet's atmosphere. You can think of it like this giant invisible filter, or maybe even a cosmic artist that's responsible for painting the sky for us. Yeah, a gauntlet. I love that word for it. Every single ray of sunlight has to run through this atmospheric gauntlet. And along the way, it's bumping into billions and billions of tiny air molecules. And that journey, well, that journey changes everything.
Okay, so let's give the main character in our story a name. It's a scientific principle called Rayleigh scattering. Don't worry about the name too much, just think of it as the sorting mechanism. It's the process that decides which colors get to paint the sky and when they get their moment to shine.
So, how does this whole scattering thing work? Well, sunlight isn't just one color, right? It's a whole rainbow packed into one beam. As that beam enters our atmosphere, it starts smacking into all those tiny gas molecules. And when it hits them, the light scatters. It just bounces off in all kinds of different directions, kind of like a cue ball breaking a rack in a game of pool.
But here's the absolute key to this whole thing, and you gotta remember this. Not all colors scatter equally. Think of it like this. Blue light has a really short wavelength, so it's like a frantic sprinter. It scatters super easily, bouncing all over the place. But red light, it has a long wavelength. It's more like a marathon runner. It's way more likely to just keep going in a straight line, pushing through obstacles.
Okay, so to really get why sunsets are red, we first have to talk about why the sky is blue during the day. It's really two sides of the same coin, and it all comes down to the path that the sunlight takes.
All right, picture this. It's noon. The sun is pretty much directly overhead. This means the sunlight is taking the shortest possible path through the atmosphere to get to your eyes. It's like a direct shortcut, straight down. So coming in, we've got that full spectrum sunlight, a nice balanced mix of all the colors of the rainbow. But the second it hits the atmosphere, the scattering begins.
And remember our little sprinter, the blue light? Because it scatters so easily, it just gets bounced around by all those air molecules all across the sky. So when you look up at noon, you're not actually seeing light coming straight from the sun. What you're seeing is all that scattered blue light coming at you from every direction. And boom, that's why the sky looks blue.
Okay, that makes sense for a blue sky. But what happens when the sun starts to set? When it gets low on the horizon? This is where our story takes a really dramatic turn. The length of the journey is about to change everything.
See, at sunset, that light isn't taking a shortcut anymore. It's coming in at a really low angle, and that forces it to travel through way, way more of the atmosphere to get to where you are.
So let's just compare these two journeys directly. At midday, you've got a short path, so the blue light scatters and fills the sky. Easy enough. But at sunset, the path is so much longer. The light hits vastly more air molecules, and, well, the result is the total opposite. On this super long journey, our little blue sprinter just runs out of steam. It gets scattered so many times that it's pretty much filtered out of the direct beam of light. It gets bounced away in all these other directions, long before it ever has a chance to reach you. So, what's left after the atmosphere has done all this filtering? What's actually left in that beam of light? Well, with all the blue and violet lights scattered away, the light that survives the journey is now just overwhelmingly red, orange, and yellow. So let's put it all together. After this epic journey, after running that atmospheric gauntlet, what are we really seeing when we look at a beautiful, fiery sunset? We're seeing the survivors. We're seeing the marathon runners. The red, orange, and yellow light. They're the only colors with wavelengths long and strong enough to power through all that extra atmosphere and make it all the way to your eyes in a straight line. You know, this quote just sums it up perfectly. The blue sky is the light that is scattered to your eye from other directions, while the red sunset is the light that is not scattered out of the direct path to your eye. It's not two different things happening, a blue sky and a red sunset. They're just two different results of the exact same process. So here's a final thought to leave you with, and it's kind of a cool one. The next time you're watching a brilliant red sunset, just remember, all that blue light that's missing, it didn't disappear. It just got scattered away. And it's probably painting a beautiful blue sky for someone somewhere else on the planet. Kind of makes you think, right? We're all connected by this one giant planetary light show. Thanks for joining me.